So Chapter 3, Scientific Measurements, we're looking at Section 3.1, Measurements and Their Uncertainty. And I'm breaking Section 3.1 into 3 parts, and so this is Part A. What's wrong with that globe? Have you figured it out yet? So here, we're connecting to your world slide. Shows the landscape from Mars when the Mars rover landed there. And the rover analyzed the geology and the climate of the planet, and all the measurements that were made have some uncertainty, so you can never be exact. If the rover took the temperature of the atmosphere on Mars, it could never be exact. There's always some uncertainty to that measurement. So, some definitions first. Accuracy. How close a measurement comes to the true value of the object being measured. If we look at a dartboard and the arrows, notice that they're all in the center, so it's a very accurate play looking at all 3 arrows there. There we go. Precision, another definition. Precision is the ability of a measurement to be reproduced consistently. Using our dartboard scenario, and let's see if this will work. I have some computer issues. Notice that all the arrows are close together. We say those are precise, but they wouldn't be accurate because they're not in the center of the target, but they're all about the same measurement. When the arrows are in the center, we can say there's good accuracy as well as precision. Here you have poor accuracy but good precision. And here you have poor accuracy as well as poor precision. Now the way to relate this to our class is think about the scales that you used yesterday, or the balances, electronic balances, if one was not calibrated properly. So that means if you put a 10-gram mass on the balance, did it really read 10 grams? Or maybe the calibration was off, so when the 10-gram mass is placed on it, let's say it reads 9 grams instead. If you use that balance throughout your experiment, you could have very good precision, but because of the inaccuracy of the balance, you would have poor accuracy. A calculation we make quite frequently is percent error. So this you should write down and put someplace in your notes so you can find it again. I also have it posted on the front wall of our classroom. Percent error is equal to your accepted value minus the measured value divided by the accepted value, and you multiply it by 100 to make it into a percentage. We'll be using this next week when we look at the density of water as well as some other liquids and objects. And those densities have an accepted value, meaning there is a correct measurement for that value or for that density, and you're going to compare your experimental value to the accepted value. And that's the end of Part A.